My name is Lee Polite, and I am the founder and president of Axion Analytical Laboratories and Axion Training Institute. Not only are we a method development laboratory for HPLC and GC methods, but we're also a training facility. In fact, I'd say our major focus is to train the world on chromatography. We run all of the hands-on HPLC and GC training courses for the American Chemical Society. We also write and teach a lot of the courses for Agilent Technologies and for a variety of other companies. So over the years, every major pharmaceutical, chemical, and petroleum company in the United States has sent their scientists to us for training. So along the way, we get to know what are the difficult spots that these customers are experiencing. GC has been around for a long time, officially since 1956. We've had a couple of, let's say, quantum leap technology changes. Certainly the introduction of the capillary column, certainly the idea of electronic pressure control, electronic flow controls, electronic pneumatic controls, I think were all very important. But to me, one of the things that has changed over the years is the level of experience of the operator. The typical GC operator today is not necessarily a trained chromatographer, probably not even a degree in chemistry or biology or even science at all. These are working folks who need to use this tool in order to generate a valid result. So I'm here to unveil those mysteries to try and get people to understand the working knowledge of GC. The reality is there's a lot of parameters that you have to set properly in order to get a valid GC result. Think about this, you have to set the correct column length, diameter, film thickness, stationary phase, mobile phase, flow rate, injection port temperature, column temperature. All of these things have to be set properly. So I see the trends going on in the GC world as fast GC. Everyone wants results faster. They also want their instrument to be more reliable and easier to set up, easier to transfer methods. So to do that, you have to simplify the instrument. You have to get people to understand how it works and make it easier to use so it's easier to troubleshoot, easier to fix, and easier to transfer methods. One of the big challenges in running a GC is the column installation. So think about this. You just bought this state-of-the-art, best instrument ever made device, and if you install the column improperly, you're going to get bad results. It'd be like me going out and buying a brand new sports car and having the salesman say, oh, by the way, make sure that when you put the key in the ignition, you put it in between 4 and 6 millimeters. If you go past that, the car will work, but it won't work right. And if you don't go in that far, then it'll sputter a little bit and it won't go as fast as it should. And so imagine I'm going to lose performance of my brand new sports car if I don't insert the key properly. That sounds crazy, but that's exactly what we do to the user in the GC world. We give them this beautiful state-of-the-art instrument, we hand them a column, and we say, go figure out how to install it. So I see column installation as something critical in the proper use of the GC. Without proper column installation, we get terrible results. So this is not a trivial thing, this is actually a pretty big point. Again, we do lots of training classes, lots of different applications out there, and a pretty common one that I hear is for big production laboratories. So let's say a big refinery, big chemical plant, they may have 40 or 50 GCs. They may have 1 or 2 people who are trained to change columns and 20 other people just operating the GCs. So in the middle of the night, when a GC goes bad, they got to call that person, wake them up in the middle of the night, have them drive to the plant in order to change a column. That's sort of a crazy concept that you have to have a specialized, especially trained person to come in just to change your columns. One of the other common complaints we get in the GC world is that the GCs are too big. Well, it's not that the GC is too big, it's just that the combination of the lab is too small and they want to add more GCs to the lab. To me, the idea of saving bench space is really important because bench space is valuable. I mean, not only is it valuable from a dollar perspective, but it is valuable in terms of there's a lot of things that I want to have going on in the lab. So if my GC can take up less space, I could either have more GCs or more stuff going on in the lab. So that would be a great thing to put on our wish list as well. Another issue we have with the GCs is that from a troubleshooting perspective, it's not always obvious what's wrong with the GC. Now, if you're an experienced chromatographer, if you've been doing this for 20 years, maybe you're pretty good at walking in the lab and seeing a tail on a peak and saying, oh, that's a dirty inlet. But again, think about the user. Think about the non-chromatographer using this great tool to measure things. Why should they have to know what tailing peaks look like? Why should they have to know how to do diagnostics? I think the GC itself can help us in terms of diagnosing problems. It should be easier to find part numbers. It should be easier to at least tell what is wrong with the instrument. So one of the things we've noticed in our business, since we're in the business of training the operators to run the GC, is that the experience level, the education level of the average user has dropped quite a bit over the last couple of decades. I don't see that as a bad thing. In fact, I see that as a good thing. I think we should be able to make the GC easy enough to use that the person using it should not have to be a chromatographer. You know, to drive a car, you don't have to be an automobile mechanic, and you shouldn't have to be. So I think that's where we're getting with the GC.